Hello, in this lecture we'll answer on two questions. In the first question we'll find out the radius of this quarter circle, and in the second question we'll find out the size of this angle theta, that is inside triangle ABC. Okay, so we'll start with the first question. In the drawing we have a quarter circle, and here side line segment BC equals to 9 units, line segment CD equals to 16 units, and line segment DL equals to 12 units, and angle OBC, this angle equals to 90 degrees, angle BCD, this angle equals to 90 degrees, and this angle CDL is also equals to 90 degrees, and our mission is to find out the radius of this quarter circle. Okay, so first of all, because of the fact that this is a quarter circle, therefore this point O must be the center of the quarter circle, so I write it down. Point O is the center of the quarter circle, and angle BOF, this angle is equal to 90 degrees, and line segment OA and line segment OF, they are both the radii of the quarter circle. So we define the radius of this quarter circle as R. Therefore here side OA will be equal to R, and here side OF, this side, will be also equal to R. They are both the radii of the quarter circle. So those three things is true in any quarter circle. Okay, so in the next step we will extend the straight line CD by a straight line until it touches the radius of the circle, that is OF, and we will define the touching point of the extended straight line CD and the radius OF as M. So actually, by doing this construction, we created here quadrilateral BCOM. So I write it down. And in quadrilateral BCOM, we have one, two, three right angles. Repeat again, quadrilateral BCOM, we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle DMO, this angle. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so here we have 270 degrees plus angle DMO must be equal to 360 degrees. Here we subtract 270 degrees from this equation, and we'll get that the missing angle DMO is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. Okay, so here this angle is a right angle, is equal to 90 degrees. So actually found out that inside quadrilateral BCOM we have four right angles, and any quadrilateral that has four right angles must be at least a rectangle. If not a square, it must be a rectangle. So we relate to quadrilateral BCOM, this quadrilateral as a rectangle. So I write it down, quadrilateral BCOM is a rectangle. And okay, so here quadrilateral BCOM is a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. So here the opposite sides of rectangle BCOM must be equal to each other. That is to say, side BC must be equal to side OM. Side BC must be equal to side OM, according to the rule that the opposite sides of a rectangle are equal to each other. Okay, but here, according to what is given us in the question, side BC equals to 9 units. So we can write down that BC equals to 9. Yeah. BC equals to 9 according to what is given as the equation. And from this equation, 9 equals to BC equals to OM. We will derive that side OM is also equals to 9 units. Okay, side OM equals to 9 units. According to what is given as the question, line segment CD is a straight line that equals to 16 units, and actually we extended the straight line CD by a straight line, and when you extend a straight line by a straight line, the result must be a straight line. So when you extended the straight line CD by a straight line, we got line segment CM. Therefore, line segment CM must be a straight line. So I write it down. CM is a straight line. Okay, and we actually have rule number 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So here we have the straight line CD. If we focus on the upper side of the straight line CD at point O, then here the sum of the angles must be equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees. So we actually can implement rule number 3 in our drawing, because we know that CM is a straight line. So if we focus on this side of the straight line CM at point D, then here the sum of the angles must be equal to 180 degrees. So which angles we have at this side of CM at point D? We have here 90 degrees. Plus this angle, that's actually angle LDM. In total, the sum of those two angles must be equal to 180 degrees according to rule number 3. Okay, I'll repeat again. Ninety degrees plus angle LDM must be equal to 180 degrees. Here we subtract 90 degrees from this equation, and we will get that the missing angle LDM equals to 180 degrees minus 90 degrees, it is 90 degrees. So we actually found out that the missing angle, it is a right angle, it's equals to 90 degrees. So this angle LDM equals to 90 degrees. Okay. Likewise, we know that OF is the radius of this quarter circle that is equal to R. So OF, line segment OF as the radius of the quarter circle must be a straight line. So write it down, OF is a straight line. So if we focus on the upper side of the straight line OF at point M, then here the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of OF at point M? We have here 90 degrees plus angle DMF. In total, the sum of those two angles must be equal to 180 degrees according to rule number 3. Okay. So here 90 degrees plus angle DMF must be equal to 180 degrees. So here we subtract 90 degrees from this equation, and we get that the missing angle DMF is equal to 180 degrees minus 90 degrees, it is equal to 90 degrees. So here angle DMF equals to 90 degrees, it is the right angle. In the next step, we do a construction from point L. We draw a perpendicular on the radius OF. Repeat again, from point L we go perpendicular on the radius OF of the border circle. So here, so actually this angle equals to 90 degrees according to our construction. And we define the touching point of the perpendicular from point L and OF is point N. Point N is the touching point between the perpendicular from point L and the radius OF. Okay, so actually by doing this construction we created here quadrilateral DLMN. You should notice that point N and point F are not merging with each other. They are very close but are not merging. Okay, so that is to say line segment ON is a little bit shorter than the radius OF. Okay, point N and F, they are very close to each other but they are not merging. So in quadrilateral DLMF we have 1, 2, 3 right angles. And the sum of right angles is 90 times 3 is 470 degrees. Plus the size of the fourth angle, that's actually angle DNN, this angle. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Because again, the sum of the angles in quadrilateral DLMN must be equal to 360 degrees, this is to say 270 degrees plus angle DLN. In total, they must be equal to 360 degrees. Here we subtract 270 degrees from this equation, and we get that the missing angle DLN, will be equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. So I found out that the missing angle is a right angle. It is equal to 90 degrees, so this angle is a right angle, it is equal to 90 degrees. So actually we found out that inside quadrilateral DLMN we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate to quadrilateral DLMN as a rectangle. I repeat again, here quadrilateral DLMN is a rectangle because it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other. So first of all, we will define side DM as edge. Here DM equals to edge according to our definition. Repeat again, we know that the opposite sides of a rectangle are equal to each other. So in rectangle DLMN, side DM must be equal to side LN. DM must be equal to LN. Repeat again. Side DM must be equal to side LN according to the rule that the opposite sides of a rectangle are equal to each other. But here, according to our definition, side dm equals to h. So we can write here, side dm equals to h. So we can write here that dm equals to h. And for this equation, L equals to dm equals to ln, we will derive that side ln, we derive that side ln is also equals to h. Here side ln equals to h. So write here that side ln equals to h. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we will get that in rectangle DLMN, side DL must be equal to side MN. Okay, so in rectangle DLMN, side DL must be equal to side MN. Repeat again, in rectangle DLMN, side DL must be equal to side MN. But according to what is given as the question, side DL equals to 12 units. So we can write here that DL equals to 12 units. And from this equation, 12 equals to DL equals to MN, we will derive that side MN is also equals to 12 units. Okay, side MN is also equals to 12 units. And side MN equals to 12 units. And therefore, if side MN equals to 12 units, it means that line segment ON equals to OM plus MN, that is to say it equals to OM, that is 9, plus MN, that is 12. 9 plus 12 is 21 units. The length of line segment ON is 21 units, while the length of the radius OF will be a little bit longer than line segment ON. So we are expecting to find the radius of the quarter circle that will be a little bit longer than 21 units. Why? Because we can see from the drawing that points N and F are very close to each other. Therefore, the radius of this quarter circle must be a little bit longer than 21 units. Okay? So, in the next step, we join points O and C together by a straight line. So here, point O is the center of the quarter circle. Point C is a point on the quarter circle itself. So this is exactly the definition of a radius. That is to say, line segment OC is the radius of this quarter circle that is equal to R according to our definition. So in the next step, we will implement the Pythagoras theorem on the right green triangle OCN. So in the right green triangle, triangle OCM, by PT is abbreviation for Pythagoras theorem. That is to say, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse is OC, therefore the square of the hypotenuse is OC square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to OM square plus CM square. Repeat again. In the right main triangle of CM, according to the Pythagoras theorem, OC square must be equal to OM square plus CM square. So here OC is R, therefore OC square is R square. Here OM equals to 9 units, therefore OM square is 9 squared, that is 81, plus CM square. Here CM equals to CD plus DM. That is to say, CM equals to CD, that is 16, plus DM, that is H. So in total, CM equals to 16 plus H. So CM equals to 16 plus H, therefore CM square will be equal to 16 plus H square. So we actually found out that according to equation number 1, R square equals to 81 plus 16 plus H square. 16 plus H. Repeat again, R square equals to 81 plus 16 plus H square. Here we will open the brackets on this side of equation number 1 and we will get that according to equation number 1, R square equals to 81 plus 16 square is 256 plus H square plus 2 times 16 times S plus 2 times 16 times H is plus 32H. So here 81 plus 256 is 337, so I write it down. According to equation number 1, we found out that R square equals to 337 plus H square plus 32H. Okay. In the next step, we will join points O and L together by a straight line. So here point O is the center of the quarter circle. Point L is the point of the quarter circle itself. That is to say, OL is the radius of this quarter circle that is equal to R. Okay, OL equals to R. So in the next step, we will implement the Pythagoras theorem on the orange right triangle, triangle OLN. I repeat again that by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the perpendiculars equals to the sum of the squares of the perpendiculars. That is to say, in the right orange triangle OLN, we get that the square of the perpendiculars is LO square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to OM square plus ON square. Repeat again. According to the Pythagoras theorem, in the right orange triangle OLN, LO square must be equal to OM square plus ON square. Okay. So here LO is R, therefore LO square is R square. And it is equal to D, it is equal to, actually it is equal to LN square I repeat again, in the right triangle LON, according to the Pythagoras theorem, LO square equals to LN square plus ON square. Here, LO square equals to LN square plus ON square. So LO square is R square, LN is H, therefore LN square is H square, plus ON square. ON is OM plus MN. That is to say, ON is OM, that is 9, plus MN, that is 12. 9 plus 12 is 21, therefore ON is 21 and ON square is 21 square. So in conclusion, according to equation number 2, we found out that R square equals to H square plus 21 squares. That is to say, according to equation number 2, we found out that R square equals to H square plus 21 square, that is actually 441. So, actually, we have here two different expressions for R square. We have R square in equation number 1 and R square in equation number 2. Therefore, we create equation number 3 that states that R square according to equation number 1 must be equal to R square according to equation number 2. Okay, R square equals to R square. So R square according to equation number 1 is 337 plus H square plus 32H, and it must be equal to R square according to equation number 2, that is actually H square plus 441. Okay, so here in equation number 3, you have H square on both sides of equation number 3, so H square will get cancelled. What is left from equation number 3 after we cancel H square? We have 337 that is equal to 337 plus 32H equals to 441. So here we subtract from this equation number 3, 337, and we get that according to equation number 3, here we have 32h, that is equal to 441 minus 337 is 104. Okay, so according to equation number 3, we found out that 32h equals to 104. Here we will divide this equation number 3 by 32, and we will get that h equals to 104 over 32, and 104 over 32 is 3.25 units. So we found out that h equals to 3.25 units. Now we will substitute h in equation number 2 by 3.25 units. According to equation number 2, r squared equals to h squared plus 441. Okay. So according to equation number 2, r squared equals to h squared. H equals to 3.25, therefore h squared will be equal to 10.5625 plus 441. 441 plus 10.5625 is 451.5625. So here we take a root out of this equation number 2, and we get that according to equation number 2, r equals to the square root of 451.5625 is equal to 21. The square root of 451.5625 equals to 21.25 units. Okay, so actually we found out that the radius of this quarter circle r equals to 21.25 units, and it is a little bit longer than 9 segment ON, that is equal to 21 units. That is to say, the radius of this quarter circle is longer by 0.25 units from line segment ON. Okay, so we finished with the first question. In the next step, I will present to you the second question, and we will solve the second question in two different methods. Okay. So here in the drawing we have triangle ABC, angle ACB, this angle equals to 40 degrees, angle ADC, this angle equals to 80 degrees, side AC equals to Y units, side DC equals to X units, side AB equals to X plus Y units, and the angle that we are looking for is angle theta, that is equal to angle ABC. Okay? So our mission is to find out the size of this angle theta, that is equal to angle ABC. So we'll start with the first method. In the first method, we'll do a construction. Here we'll extend side BC by straight line by y units. Repeat again, we'll extend BC by y units. So here, when this point is point A, then it means that line segment CE equals to y units according to our construction. Repeat again, line segment CE equals to y units according to our construction. In the next step, we join points A and D together by a straight line. So we created here triangle ACE. So we'll copy triangle ACE and we'll analyze triangle ACE. I'll copy triangle ACE in a new page and we'll analyze triangle ACE. So this is triangle ACE that I copied from the original drawing. Here, side CE equals to y and side AC equals to y. Therefore, those two sides are equal to each other because they are both equal to y. So, side AC equals to side CE. So the fact that they are both equal to y, it means that they are equal to each other. And we have the rule that in front of equal angles in a triangle, there are equal sides. So in front of those two in front of equal sides in the triangle, there are equal angles. So in front of those two sides, we have those two angles. So those two angles must be equal to each other according to the rule that I mentioned. That is to say, angle CAE, this angle, must be equal to this angle that is actually angle AEC. And so those two angles must be equal to each other. So if we define angle AEC as alpha, here angle AEC equals to alpha according to our definition, then from this equation angle CAE equals to angle AEC equals to alpha, we will derive that angle CAE is also equals to alpha. Angle CAE is also equals to alpha. So this angle equals to alpha. So actually those two angles they are both equal to each other, they are both equal to alpha. In the next step, here we know that this angle ACB equals to 40 degrees. So I'll copy angle ACB in this drawing from the original drawing. So this angle ACB, equals to 40 degrees according to what is given us in the question. Okay, so in the next step I present to you the exterior angle theorem, and we implement the exterior angle theorem in this triangle ACE. So what is the exterior angle theorem? The exterior angle theorem is true in any triangle. So here we have triangle ABC, that could be any triangle. This is triangle ABC. And in triangle ABC, we have three interior angles: angle alpha, angle beta, and angle gamma. So I repeat again that angles alpha, beta, and gamma are defined as an interior angles of triangle ABC. Why they are defined as an exterior angles? Because of the fact that they are located inside triangle ABC. While this angle ACD, this angle ACD is defined as an exterior angle. So we define the exterior angle ACD as E. So I write down that E is defined as an exterior angle. Why E is an exterior angle? Because it is located outside triangle ABC. And what is the length? What is the size of the exterior angle ACD, that is equal to E? The size of the exterior angle E, according to the exterior angle theorem, it is equal to the sum of the two interior angles that are not adjacent to it. Here, angle gamma is adjacent to angle E, and the two other interior angles that are not adjacent to it are alpha and beta. And the sum of those two angles, alpha and beta, is alpha plus beta. Therefore, the exterior angle E equals in size to alpha plus beta. I repeat again. According to the exterior angle theorem, the size of the exterior angle E equals to the sum of the two angles interior angles that are not adjacent to it, and the two interior angles that are not adjacent to it is alpha plus beta, and the sum of angles alpha and beta is alpha plus beta. Therefore, the size of the exterior angle E is equal to alpha plus beta. Now we will implement the exterior angle theorem in triangle ACE. So here, alpha and alpha are the two interior angles, while angle ACB is an exterior angle. So I write it down. Alpha and alpha are interior angles, and angle ACB, this angle, is defined as an exterior angle. Okay, and what is the size of the exterior angle ACB? The size of the exterior angle ACB will be equal to the sum of the two interior angles that are not adjacent to it. And the two interior angles that are not adjacent to it are alpha and alpha. Therefore, the size of the exterior angle ACB will be equal to alpha plus alpha, that is 2 alpha. Okay, but according to what is given as the question, angle ACB equals to 40 degrees. And from this long equation, we derive that 2 alpha equals to 40 degrees. 2 alpha equals to 40 degrees. Here we will divide this equation by 2 and we will get that angle alpha equals to 40 degrees over 2 is 20 degrees. Angle alpha equals to 20 degrees, so here alpha equals to 20 degrees, and here also alpha equals to 20 degrees. Okay, so here we actually found out that angle CAE equals to 20 degrees. This is angle CAE that is equal to 20 degrees, is equal to alpha that is equal to 20 degrees, and here angle AEC that is equal to alpha equals to 20 degrees. This is angle AEC that is equal to alpha that is equal to 20 degrees. Okay. Here we focus on triangle ADC. In triangle ADC, this angle equals to 80 degrees. This angle equals to 40 degrees. 80 degrees plus 40 degrees is 120 degrees. So the sum of of two angles in triangle ADC is 120 degrees. Therefore, the third angle must be equal to 60 degrees. Why? Because 60 degrees plus 120 degrees, 60 degrees plus 120 degrees equals to 180 degrees. So in order to complete the sum of the angles in triangle ADC to 180 degrees, this angle must be equal to 60 degrees. Okay, so in the next step, I'll copy triangle ADE in a new page and we'll analyze triangle ADE. Okay, so here, this is triangle ADE. This is triangle ADE that I copied from the original drawing. Angle BAE equals to 60 degrees plus 20 degrees, that is 80 degrees. This angle ADE is also equals to 80 degrees. And here, side DE equals to DC plus CE. Again, DE equals to DC plus CE. That is to say, DE equals to DC, that is X, plus CE, that is Y. So in total, DE equals to X plus Y. So I found out that in DE equals to X plus Y. And in this triangle ADE, those two angles are equal to each other. And we have the rule that in front of equal angles in the triangle, there are equal sides. In front of this angle, we have side DE. And in front of this angle, we have side AE. And according to the rule that I mentioned, those two sides that are located in front of equal angles must be also equal to each other. That is to say, DE equals to AE. DE equals to AE. But according to what we just right now found out, that D equals to X plus Y. Here D equals to X plus Y. And from this equation, X plus Y equals to D equals to AE. we will derive that AE is also equals to x plus y. Here AE equals to x plus y. Okay. In the next step, I will copy the big triangle, triangle ABE. In this page, we will analyze triangle ABE. So actually, this is triangle ABE that I copied from the original drawing. Angle AB equals to x plus y according to what is given as the equation, and angle AE equals to x plus y according to what we have already found out. This angle equals to theta according to what is given as the equation, and we have already found out that angle AEB is equal to 20 degrees. So those two sides, they are both equal to x plus y, therefore they are equal to each other. So I can write down that side AB equals to side AE equals to x plus y. Because of the fact that both sides are equal to each other, it means that because of the fact that both sides are equal to x plus y, it means that they are equal to each other. And because of the fact that AB equals to AE, it means that triangle ABE is an isosceles triangle. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of this side, side AB, we have 20 degrees. And in front of this side AE, we have angle theta. And those two angles must be equal to each other. Why? Because they are located in front of equal sides. Okay? I repeat again, those two angles must be equal to each other because of the fact that they are located in front of equal sides. AB equals to AE. So actually found out that angle theta equals to 20 degrees. We finished with the first method. Here, this angle theta equals to 20 degrees. So we finished with the first method. In the next step, I'll present to you the second method. Here, in the second method, we'll focus on triangle ADC. In triangle ADC, this angle equals to 80 degrees, this angle equals to 40 degrees. 80 degrees plus 40 degrees is 120 degrees. So the sum of those two angles in triangle ABC is 120 degrees. Therefore, the third angle must be equal to 60 degrees, because 60 degrees plus 120 degrees equals to 180 degrees. And the sum of the angles in this triangle ADC, must be equal to 180 degrees. Therefore, this angle must be equal to 60 degrees. We define side AD as A, and I will present to you the law of sines, and we will implement the law of sines in triangle ADC, and then we will implement the same law in triangle ABD. So what is the law of sines? The law of sines is true in any triangle. So here we have triangle ABC that could be any triangle. This is triangle ABC that could be any triangle. Side BC equals to A units in its length. Angle BAC equals to capital A degrees. The side of angle AC is B units, and angle ABC, this angle ABC equals to capital B degrees. And finally, the length of side AB is C units, and angle ACB, this angle equals to capital C degrees. So according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. I repeat again, according to the law of sines, in this triangle ABC, A over sine A equals to B over sine B equals to C over sine C. Okay, so now we will implement the law of sines in triangle ADC. Okay, this is triangle ADC. So here we'll implement the law of sines in triangle ADC. The red triangle in triangle ADC. So I write down in triangle ADC. The green triangle ADC, according to the law of sines, we will get that DC over sinus 60 degrees equals to AD over sinus 40 degrees and it is equal to AC over sinus 80 degrees. Okay, this equation number 1, is the implementation of the law of sines in the green triangle ADC. So according to the law of sines, DC over sinus 60 degrees equals to AD over sinus 40 degrees equals to AC over sinus 80 degrees. Okay. Here DC equals to x, so we substitute DC by x over sinus 60 degrees is equal to AD equals to A, so substitute AD by A, so it is A over sinus 40 degrees and it is equal to AC is Y, so we substitute AC by Y, so it is AC over sinus 80 degrees. Okay, so we have here three expressions that are equal to each other. Each expression equals to the other expression. Therefore, we can define that the value of the three expressions 1, 2, 3 are equal to k. Okay, it's possible to do it because we know that the three expressions are equal to each other. Therefore, we can define that the value of the three expressions that are equal to each other is equal to k. And in the next step, we will derive the first equation from this long equation. Here, this expression equals to k. Therefore, we can write down that according to equation number 1, x over sinus 60 degrees equals to k here we multiply this equation number 1 by sinus 60 degrees and we get that the value of x is k times sinus 60 degrees. Okay, we found out the value of x. In the next step, we derive from this long equation the second equation. Those two expressions are equal to each other. So here we can write down that this will be equation number 2. That A over sinus 40 degrees equals to k. Okay, this is equation number 2, that A over sinus 40 degrees equals to k. Here we multiply this equation number 2 by sinus 40 degrees and we will get that according to equation number 2, A equals to k times sinus 40 degrees And finally, you can derive the further equation from this lower equation. Those two expressions are also equal to each other. So here this will be equation number 3 that states that y over sinus 80 degrees equals to k. So here we multiply this equation number 3 by sinus 80 degrees, and we will get that according to equation number 3, y equals to k times sinus 80 degrees. Okay, so we actually have three expressions for x, y, and a. In the next step, we will implement the law of sines in a triangle ABD. Repeat again, we will implement the law of sines in this triangle ABD. Okay. So we will implement the law of sines in the orange triangle ABD. So in the orange triangle ABD, according to the law of sines, in the orange triangle. But before that, we will find out the value of angle ADB. Here, we know that BC is a straight line, and we know that according to rule number 3, if you focus on the upper side, BC is one side of triangle ABC, it must be a straight line. Okay, so BC is a straight line. So if you focus on the upper side of the straight line BC at point D, then the sum of the angles here must be equal to 180 degrees. So which angles we have on the upper side of BD, at the upper side of the straight line BC at point D, this angle equals to 80 degrees plus this angle ADB. So 80 degrees plus angle ADB must be equal to 180 degrees. If we subtract 80 degrees from this equation, we get that the missing this angle equals to 100 degrees. As you can see here, 100 degrees plus 80 degrees is 180 degrees. Okay, and the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, we found out that this angle equals to 100 degrees, so according to the law of sines, we get that AB over sinus 100 degrees equals to AD over sinus theta. I'll repeat again. According to the law of sines in the orange triangle ABD, AB over sinus 100 degrees equals to AD over sinus theta. AB equals to x plus y, so we substitute AB by x plus y, and we get that according to equation number 2, AB is x plus y over sinus 100 degrees, it is equal to AD, and AD is A, so we substitute AD by AD over sinus theta. So we actually found out that according to equation number 2, x plus y over sinus 100 degrees equals to A over sinus theta. Now we substitute x, y, and A by the values that we found for them. Okay, here x is equal to k times sinus 60 degrees plus y, and y equals to k times sinus 80 degrees, all divided by sinus 100 degrees, and it is equal to A is k times sinus 40 degrees over sinus theta. So here we have k on both sides of the equation, so k will get cancelled. What is left from equation number 2 after we cancelled k? What is left is actually we have in this side of equation number 2 we have sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees. It is equal to sinus 40 degrees over sinus theta. Now we will cross multiply this equation number 2, and we get that according to equation number 2, sinus theta times sinus 60 degrees plus sinus 80 degrees equals to sinus 100 degrees times sinus 40 degrees. Now we divide this equation number 2 by sinus 60 degrees plus sinus 80 degrees, and we get that according to equation number 2, sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 80 degrees plus sinus 60 degrees. Okay, so here we have the trigonometric identity that states that sinus 2a equals to 2 times sine A times cosine A we'll use this trigonometric identity for sinus 40 degrees. Actually, sinus 40 degrees equals to sinus 2 times 20 degrees. That is equal to, according to this trigonometric identity, it is equal to 2 times sinus 20 degrees times cosine 20 degrees. So in conclusion, we found out that sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. Okay, so now we can substitute sinus 40 degrees in equation number 2 by 2 times sinus 20 degrees times cosine 20 degrees. Okay, but before that, we have another trigonometric identity. The trigonometric identity is that sinus 90 degrees plus theta equals to cosine theta. We'll use this trigonometric identity for sinus 100 degrees. According to this trigonometric identity, sinus 100 degrees equals to sinus 90 degrees plus 10 degrees, and sinus 90 degrees plus 10 degrees, according to this trigonometric identity, sinus 90 degrees plus theta equals to cosine theta. Here, sinus 90 degrees plus 10 degrees, according to this trigonometric identity, will be equal to cosine 10 degrees. So in conclusion, we found out that sinus 100 degrees equals to cosine 10 degrees, therefore we can substitute sinus 100 degrees by cosine 10 degrees. Okay, so we'll do the substitution of the two expressions now, and we'll get that according to equation number 2, sinus theta equals to sinus 40 degrees, and we have already found out that sinus 40 degrees is equal to 2 times sinus 20 degrees times cosine 20 degrees. And we have to multiply it by sinus 100 degrees, and we already found out that sinus 100 degrees equals to cosine 10 degrees, so we substitute sinus 100 degrees by cosine 10 degrees, and we have to divide on the string by the numerator by sinus 80 degrees plus sinus 60 degrees. Okay, we have here another trigonometric identity for sinus 80 degrees plus sinus 60 degrees. According to the following trigonometric identity, sinus D plus sinus C equals to 2 times sinus D plus C over 2 times cosine D minus C over 2. So according to this trigonometric identity, we get that the value of sinus 80 degrees plus sinus 60 degrees will be 2 times sinus D plus C is 80 degrees plus 60 degrees, that is 140 degrees, and 140 degrees over 2 is 70 degrees. So it is 2 times sine 70 degrees times cosine D minus C is 80 degrees minus 60 degrees, that is 20 degrees, and 20 degrees over 2 is 10 degrees. So in conclusion, we found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. In the next step, we will substitute sinus 80 degrees plus sinus 60 degrees in this equation number 2 by 2 times sinus 70 degrees times cosine 10 degrees. And we'll get that according to equation number 2, sinus theta equals to 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees over sine 80 degrees plus sine 60 degrees, and we have already found out that sine 80 degrees plus sine 60 degrees equals to 2 times sine 70 degrees times cosine 10 degrees. Okay, so here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. We have cosine 10 degrees in the numerator and cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled. So what is left from equation number 2 after we cancel the two expressions? Here, what is left is actually here we have sinus theta that is equals to sinus 20 degrees times cosine 20 degrees divided by sinus 70 degrees. Now I present to you the last trigonometric identity, and you use the last trigonometric identity for sinus 40 degrees. The last trigonometric identity is that sinus 90 degrees minus theta equals to cosine theta. According to this trigonometric identity, we'll get that sinus 70 degrees equals to sinus 90 degrees minus 20 degrees, and sinus 90 degrees minus 20 degrees equals to, according to the trigonometric identity, that sinus 90 degrees minus theta equals to cosine theta. We get that sinus 90 degrees minus 20 degrees equals to cosine 20 degrees. So in conclusion, we found out that sinus 70 degrees equals to cosine 20 degrees. Now we substitute sinus 70 degrees by cosine 20 degrees in equation number 2. So according to equation number 2, we found out that sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. But we just right now found out that sinus 70 degrees equals to cosine 20 degrees. Therefore, we substitute sinus 70 degrees by cosine 20 degrees. So here we have cosine 20 degrees in the numerator and we have cosine 20 degrees in the denominator. So cosine 20 degrees will get cancelled. And we left only, according to equation number 2, sinus theta equals to sinus 20 degrees, and we know that if sinus alpha equals to sinus beta, it means that alpha equals to beta. Here sinus theta equals to sinus 20 degrees means that theta equals to 20 degrees. So we found out in the second method also that theta equals to 20 degrees. So in the next step I will summarize the lecture. We'll start with the first question, of course. in the drawing we have a quarter circle. Line segment BC equals to 9 units, line segment CD equals to 16 units, and line segment DL equals to 12 units. Angle OBC, this angle equals to 90 degrees, angle BCD equals to 90 degrees, and this angle CDL also equals to 90 degrees, and our mission is to find out the radius of this quarter circle. Okay, so because of the fact that this is a quarter circle, it means that point O is the center of the quarter circle. This angle equals to 90 degrees, and side AO and side OF, they are both the radii of the quarter circle that is equal to R according to our definition. Okay, so in the next step we extended the straight line CD by a straight line until it intersects with the radius OF. We define the touching point of the extended straight line CD and OF as M. By doing this construction, we created a quadrilateral BCOM. Inside quadrilateral BCOM, we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation, and we found out that the missing angle DMO, this angle equals to 90 degrees. So actually we found out that inside quadrilateral BCOM, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral BCOM as a rectangle, and you know that the opposite sides of a rectangle are equal to each other. That is to say BC equals to OM. BC equals to OM, but according to what is given as the question, BC equals to 9. So here we have 9 that equals to BC equals to OM, and from this equation we derive that OM is also equals to 9. Here OM equals to 9. Then we know that CD is a straight line. We extended the straight line CD by straight line, therefore the result is CM, so CM must be also a straight line, because when you extend the straight line by straight line, the result must be a straight line. So we know that CM is a straight line, and according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line CM at point D, then the sum of the angles here must be equal to 180 degrees. So which angles we have at this side of CM at point D? We have here this angle that is equal to 90 degrees plus angle at DM. In total, the sum of those two angles must be equal to 180 degrees. So here 90 degrees plus angle ADM must be equal to 180 degrees according to rule number 3. Here we subtracted 90 degrees from this equation and found out that the missing angle ADM equals to 90 degrees. This angle equals to 90 degrees. Likewise, DFOF is the radius of the quarter circle, therefore it is absolutely a straight line. Okay, OF is a straight line. And we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line OF at point M, then the sum of the angles here must be equal to 180 degrees. So which angles we have on the upper side of OF at point M? We have here this angle equals to 90 degrees plus angle DMF. In total, they must be equal to 180 degrees according to rule number 3. 90 degrees plus angle DMF must be equal to 180 degrees. We subtracted 90 degrees from this equation and found out that the missing angle DMF equals to 90 degrees. That is to say, this angle equals to 90 degrees. Then from point L, we draw perpendicular on OF. So this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point L and OF as N. Okay, so here we created quadrilateral DLMN that has actually 1, 2, 3 right angles. I repeat again, in quadrilateral DLMN LMF, we have 1, 2, 3 right angles, and so the sum of 3 right angles is 270 degrees plus the size of the fourth angle, that is actually DLN, this angle. In total, the sum of those 4 angles must be equal to 360 degrees. We subtracted 270 degrees from this equation and found out that the missing angle, this angle DLN, equals to 90 degrees. So actually we found out that inside quadrilateral DLMN we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So quadrilateral DLMN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So we define DM as H, and here DM must be equal to LN. DM must be equal to LN, but according to our definition, DM equals to H. So from this equation, H equals to DM equals to LN, we will derive that LN is also equals to H. Here, LN is also equals to H. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we get that DL equals to MN. DL equals to MN, but according to what is given as the question, DL equals to 12 units. So you can write here that DL equals to 12, and from this equation 12 equals to DL equals to MN, we will derive that MN is also equals to 12 units. Here MN also equals to 12 units, and then we join points O and C together by a straight line. Point O is the center of the quarter circle, point C is the point of the quarter circle itself, therefore OC is the radius of the quarter circle, that is equal to R according to our definition. Then we implemented the Pythagoras theorem on the right triangle, triangle COM. According to the Pythagoras theorem, CO square equals to CM square plus OM square. CO square equals to OM square plus CM square. CO is R, so CO square is R square. OM is 9, OM square is 9 square, that is 81. CM is CH plus DM. CM is CD plus DM, that is to say CM is CD, that is 16, plus DM, that is H. So CM equals to 16 plus H. CM equals to 16 plus H, therefore CM square is 16 plus H square. So according to equation number 1, we found out that R square equals to 81 plus 16 plus H square. We opened the brackets on this side of equation number 1, and we found out that R square equals to 81 plus 81, and 16 plus H square equals to 16 squared, that is 256, plus H square plus 2 times 16 times H, that is 32H. So here 81 plus 256 is 377. So in conclusion, we found out that according to equation number 1, R square equals to 337 plus H square plus 32H. Then we join points O and L together by a straight line. OL is the radius of this quarter circle, that is equal to R, and according to the Pythagoras theorem, OL square equals to LN square plus NO square. OL square equals to LN square plus NO square. NO equals to R, therefore NO square is R square. LN equals to H, therefore LN square is H square. ON equals to 9 plus 12, that is 21, therefore NO square equals to 21 square. So, and 21 square is 441. Therefore, according to equation number 2, we found out that R square equals to H square plus 441. So we have two different expressions for R square. Therefore, we can create equation number 4 equation number 3 that states that R square according to equation number 1 must be equal to R square according to equation number 2. R square according to equation number 1 is 337 plus H square plus 32H, and it must be equal to R square according to equation number 2, that is H square plus 441. Here we have H square on both sides of the equation, so H square will get cancelled. So we found out after we cancelled H square that 337 plus 32H equals to 441. Here we subtracted from this equation number 3, 337, and we found out that 32H equals to 441 minus 337 is 104. So in conclusion, we found out that 32h equals to 104. We divided this equation by 32 and found out that h equals to 104 over 32, that is 3.25. So h equals to 3.25, then we put the value of h inside equation number 2, inside h in equation number 2. According to equation number 2, r squared equals to h squared plus 441, and h equals to 3.25, therefore h squared will be equal to 3.25 squared, that is 10.5625. So in conclusion, found out that r squared equals to 10 plus 441, 10.5625 plus 441, that is actually 451.5625. We took out for this equation and found out that r equals to 21.25. Here the radius of this quarter circle is 21.25, that is a little bit greater than ON, that is 21. Then I presented to you the second question and we found the value of theta in two different methods. Okay, so here in the drawing we have triangle ABC, angle ACD equals to 80 degrees, angle ADC equals to 80 degrees, DC equals to X, AC equals to Y, AB equals to X plus Y, and our mission is to find out the size of this angle theta. So in the first method, we did the construction, we extended side BC by Y units, so here CA equals to Y, we joined points A and D together by straight line, and then I copied the triangle ACE in this page, and we analyzed triangle ACE. C equals to Y, AC also equals to Y, therefore both sides are equal to Y, therefore they are equal to each other. That is to say, AC equals to CE. And we know that in front of equal sides in the triangle there are equal angles. Therefore those two angles that are located in front of equal sides, they must be equal to each other. So if one angle is alpha, then the other angle must be also equal to alpha, because they are equal to each other. Okay, and then I copied angle ACB here, and we know that angle ACB equals to 40 degrees according to what is given as the question. And then I presented to you the exterior angle theorem. According to the exterior angle theorem, the size of the exterior angle, angle E, equals to alpha plus beta, that is the sum of the two interior angles that are not adjacent to it. We implemented rule number, this rule, the exterior angle theorem, in triangle ACE. According to the exterior angle theorem, the exterior angle ACB equals to alpha plus alpha, that is to say angle ACB equals to alpha plus alpha, that is 2 alpha, and according to what is given as the equation, angle ACB equals to 40 degrees. So from this equation, 40 degrees equals to angle ACB equals to alpha plus alpha, we will derive that 40 degrees equals to 2 alpha, and we divided this equation by 2, and we found out that alpha equals to 28 degrees. So here, this angle that is alpha equals to 20 degrees, and this angle that is also alpha, it is also equals to 20 degrees. Then I copied triangle ADE in this new page, and we analyzed triangle ADE. This is triangle ADE. This angle DAE equals to 60 degrees plus 20 degrees, that is 80 degrees. This angle ADE that equals to 80 degrees according to what is given as the question. So in triangle ADE, here DE equals to X plus Y, and here those two angles in triangle ADE are equal to each other, and we know that in front of equal angles in the triangle there are equal sides. In front of this angle we have side DE, in front of this angle we have side AE, and according to the rule that I mentioned, DE must be equal to AE, but DE equals to X plus Y. So I can write here that D equals to X plus Y, And from this equation, x plus y equals to d equals to AE, we will derive that AE is also equal to x plus y. Then I copied the big triangle ABE here. Here, side AB equals to x plus y, according to what is given as the question. Side AE equals to x plus y, according to what we just right now found out. This angle equals to 20 degrees, according to what we have already found out. This angle equals to theta, according to what is given as the question. Those two sides, they are both equal to x plus y, therefore they are equal to each other. That is to say, side AB equals to side AE. So triangle AB is an isosceles triangle, and we have the rule that in front of equal sides in the triangle there are equal angles. So in front of this side AB we have 20 degrees. In front of this side AE we have theta. And because of the fact that those two angles are located in front of equal sides, they must be also equal to each other. That is to say, theta must be equal to 20 degrees. So I found out that the answer to the question is angle theta here equals to 20 degrees. Then I presented to you the second method. In the second method, we focus on triangle ADC. This angle equals to 40 degrees, this angle equals to 80 degrees. 40 degrees plus 80 degrees is 120 degrees, so this angle must be equal to 60 degrees. In order to complete the sum of the angles in triangle ADC to 180 degrees, this angle must be equal to 60 degrees, because 120 degrees plus 60 degrees equals to 180 degrees. Okay, then we defined side AD as A. Then I presented to you the law of sines. According to the law of sines, here A over sine A equals to B over sine B equals to C over sine C. And this equation is true in any triangle. Then we implemented the law of sines in the green triangle, triangle ADC. According to the law of sines, we get that DC over sinus 60 degrees equals to AD over sinus 40 degrees equals to AC over sinus 80 degrees. DC equals to X, AD equals to A, and AC equals to Y. And we defined those three expressions are equal to each other, so we defined them as K. They are equal to K. And then we derived the first equation from the longer equation, that X over sinus 60 degrees equals to K. We multiplied equation number 1 by sinus 60 degrees and found out that X equals to K times sinus 60 degrees. Then we derived the second equation from this longer equation. Those two expressions are equal to each other. That is to say, A over sinus 40 degrees equals to K. We multiplied this equation by sinus 40 degrees and found out that A equals to K times sine 40 degrees. Then finally those two expressions are equal to each other. So that is to say, Y over sinus 80 degrees equals to K. We multiplied this equation by sinus 80 degrees and found out that Y equals to K times sinus 80 degrees. So we created here three expressions for X, Y, and A. Then we implemented the law of sines in the orange triangle, triangle ABD. Here, this angle equals to 90 degrees. BC is a straight line. This angle equals to 80 degrees. Therefore, this angle must be equal to 100 degrees in order to complete the sum of the angles. In order to, according to the rule that the sum of the angles on one side of the straight line is 180 degrees. So if this angle equals to 90 degrees, this angle must be equal to 100 degrees, because 100 degrees plus 80 degrees is 180 degrees. That is the sum of the angles on one side of a straight line. Okay, so this angle equals to 100 degrees. Then according to the law of sines, in the orange triangle, triangle ABD, AB over sinus 100 degrees equals to AD over sinus theta. I'll repeat again. In triangle ABD, AB over sinus 100 degrees equals to AD over sinus theta. AB is X plus Y, and AD is A. Okay? Then we substituted X, Y, and A. by the values that we found them previously. Here x is k times sinus 60 degrees, y is k times sinus 80 degrees, and a is k times sinus 40 degrees. We have k on both sides of the equation, so k will get cancelled. Then, after we cancel k, we're left only with sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees, that is equal to sinus 40 degrees over sinus theta. Here we cross multiply this equation and we got that sinus theta times sinus 60 degrees plus sinus 80 degrees equals to sinus 100 degrees times sinus 40 degrees. Then we divided this equation number 2 by sinus 60 degrees plus sinus 80 degrees, and we found out that sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 80 degrees plus sinus 60 degrees. Then we use the trigonometric identity that sinus 2a equals to 2 sine a cosine a in order to find out the value of sinus 40 degrees. Sinus 40 degrees is sinus 2 times 20 degrees, and according to this trigonometric identity, sinus 2 times 20 degrees equals to 2 times 20 degrees cosine 20 degrees. So we can substitute sinus 40 degrees by 2 times sinus 80 degrees times cosine 20 degrees. Then we have the trigonometric identity that sinus 90 degrees plus theta equals to cosine theta. We use this trigonometric identity for sinus 100 degrees. Sinus 100 degrees equals to sinus 90 degrees plus sinus 10 degrees. Then, and according to this trigonometric identity, we get that sinus 90 degrees plus 10 degrees equals to cosine 10 degrees. So we can substitute sinus 100 degrees by cosine 10 degrees, and we can substitute sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees. We did it, and we got that according to equation number 2, sinus theta equals to, we substitute sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees, and we substituted sinus 100 degrees by cosine 10 degrees. So we got this expression, and all divided by sinus 80 degrees plus sinus 60 degrees. We have the trigonometric identity that sinus d plus sinus c equals to 2 sine d plus c over 2 times cosine d minus c over 2. So according to this trigonometric identity, we will get that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus d is 80, c is 60. So 80 plus 60 is 140, and 140 over 2 is 70 degrees times cosine d minus c over 2. D is 80, c is 60, so 80 minus 60 is 20, and 20 over 2 is 10. So in conclusion, found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. Now we can substitute sinus 80 degrees plus sinus 60 degrees in the denominator of equation number 2 by 2 times sinus 70 degrees times cosine 10 degrees. We did it, and we got that sinus theta equals to 2 times sin 20 degrees times cosine 20 degrees times cosine 10 degrees, and we substituted sinus 80 degrees plus sinus 60 degrees by 2 times sinus 70 degrees times cosine 10 degrees. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. We have cosine 10 degrees in the numerator and cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled, and we're left only with sinus theta, that is equal to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. Then we had the last trigonometric identity that sinus 90 degrees minus theta equals to cosine theta. We use this trigonometric identity for sinus 70 degrees. Sinus 70 degrees equals to sinus 90 degrees minus 20 degrees. So according to this trigonometric identity, sinus 90 degrees minus 20 degrees equals to cosine 20 degrees. So in conclusion, we found out that sinus 70 degrees equals to cosine 20 degrees. So we can substitute sinus 70 degrees by cosine 20 degrees in equation number 2. And we will get that sinus theta equals to sinus 20 degrees times cosine 20 degrees. And we substitute cosine 70 degrees by, we substituted sinus 70 degrees by cosine 20 degrees. And we got here cosine 20 degrees in the numerator, we have cosine 20 degrees in the denominator, cosine 20 degrees we get cancelled, and finally we got that sinus theta equals to sinus 20 degrees, and if sinus alpha equals to sinus beta, it means that alpha equals to beta. So here, if sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees. So in both methods, we found out that the size of this angle theta, it is equal to 20 degrees. Okay? Thank you very much.